presentation. You can write any question you want during the presentation. I will try to reply them after I finish the chapters, right? My name is Gonzalo Acosta. I'm working in Netguru already almost 2 years by now, and I will introduce Kotlin as an alternative to Java in Android development, right? So this time we will treat only some part of the Kotlin language. It's huge. I mean, it has a lot of features. So 1 hour is not enough time for it. Basically, our agenda includes what is Kotlin, why replace Java and not continue using Java, the basic syntax in Kotlin, something called null safety in Kotlin, default arguments and name arguments, data classes, hierarchies, delegation, and the object keyword, if, when, and loop expressions, right? Smartcast and time inference, extension functions, higher than functions, and lambda expression, everything related with functions. Some extra that I couldn't like make them in the same chapter, so I just put some extras of Kotlin and some resources so you can continue learning about Kotlin. That it was really useful for me, so probably it will be for you as well. So let's start with what is Kotlin exactly. So as you know, it's a programming language and it's developed by JetBrains. And yes, JetBrains the same the one that developed the IntelliJ IDEA IDE, right? That the Android Studio is based on. Its first appearance was in 2011. So they start working in Kotlin 1 year before it, and they make it open source in February of 2012, right? The reason of why they start a new language, JetBrains, is because they claim that most of the language didn't have the features they were looking for, so they just start a new language. The first release was the version 1 in February 2016, so it had like a lot of development in the middle. Like I said, it's open source. You can check the repository in that page, right? In that GitHub repository. And from 2017, 17, it includes first-class support from Google. What does it mean? That, for example, the Android Studio 3.0 includes Kotlin out of the box. You don't need to install any extras or plugins to use it. It's statically typed. That means that all the types of the variables are known at compile time, but not always is necessary indicate the type of the variable. We'll see that later, but it sounds weird for Java developers, but it's like that. Of course, it's a language made for the JVM, right? It compiles to Java bytecode, but also it can be compiled to JavaScript code or to machine code, right? It's a general purpose language. That means that it's not only for Android development, it can be used also for server and desktop, right? It focuses on interoperability. Sorry, wrong word. That means that interoperability with Java, for example, is also in safety, clarity, and tooling support. Especially because it's developed by this guy from JetBrains, so they include a lot of tools for it. So let's talk about why replace Java. I mean, why we need a replacement with Java for Java in Android development in Android. So as we know, Java isn't a modern language anymore, right? I mean, they include some features in the last release of Java, that can be 7 or 8, especially. But for example, for us Android developers, you cannot include Java in your daily releases because Android doesn't support. I mean, it's supported from the API 24, and sometimes we want to develop application for all the versions of Android. As I said, Android doesn't fully support Java 8, right? Java has some very well documented issues. Can be the endless try catch block, the lack of extendability, or the lack of support for functional programming, right? It has a lot of boilerplate code. For example, every time you want to write a class, you have to write a toString hash code equals or copy method for all the classes. You have to explicitly define the class properties, right? It's not null safe by default. I mean, you can include annotations, but by default, not all the Java developers are need to do that, right? You don't need to do that. The compiler is not smart enough, sorry. And why use Kotlin from the other side? What includes Kotlin? Well, basically, Kotlins cost nothing to adopt, especially for us Java developers. You have a lot of tools, for example, one-click Java to Kotlin convert tool. I mean, you can write code in Java and convert it to Kotlin. And you can use it also in already existing projects. For example, you have a Android project, right? You have all the classes in Java. You can start writing right now a class or a file in Kotlin and use it without any problem. As I was saying, then the syntax is really lean and intuitive. You will see it's really easy to understand. It has interoperability with Java. You can use all the existing libraries and frameworks written in Java in Kotlin. And by default doesn't need any wrapper or anything weird. You just use the libraries. It imposes no runtime overhead. That means that it will not take more time than Java to compile. By now, because Kotlin has already some years in the market, maybe before the first release, there were people playing a little bit with that, and right now, actually, it has a lot of open source projects that you can check and see how they do different things, right? It has, because it was developed by JetBrains, it has a lot of productivity and chasing tools. And one of really important thing for us Android developers is that it targets Java 6, right? So we can use it for all the Android versions. Some comparison between Java and Kotlin. Let's start with some issues addressing Kotlin. Java issues, right? Addressing Kotlin. So null reference basically are controlled by the type system. So that means that we will not have more, aims, or Kotlin tries to not produce any more null pointer exceptions. There are no row types. For example, it's not possible if we have a box for some type, it's not possible to use only box. That's it. In Java is made to support all the versions of Java, and Kotlin will not have that. Raising Kotlin invariants, like all the other collections. Again, in Java is done like that because to support all the versions of Java when polymorphism didn't exist, right? Kotlin has proper function types. I can indicate what will receive a function and what will return. You cite variances without wildcards. If you know wildcards, you know that it's quite complicated at the beginning to understand how they work. And in Kotlin, they made it really, really simple to understand. And then you don't have no check exceptions. I mean, never. I mean, the compiler will never say anything if you don't. I don't know, write a block with try catch. It will never return an exception. And then what Java has that Kotlin does not have, right? Doesn't mean that it's good or bad. It's, I mean, difference between both of them, right? So in Java, of course, we have check exceptions. We have primitive types that are not classes like, I don't know, int or character or that kind. In Kotlin, we don't have. Maybe you will think, okay, it will not be or generate good performance, but we'll see that yes, actually it has good performance because depending of what you're doing with a type, Kotlin will compile into a primitive type or a class. We don't have static members, not private fields, right? Wildcards, like I said, again, doesn't mean that it's good or bad, but yes, we don't have wildcards. So after compilation and give my why we should change to Kotlin, let's start a little bit more with seeing Kotlin features. Let's start with the basic syntax. Fun, val, and var. We will learn what it means, all of them. But first, we will define we will talk about how to define package in Kotlin. So, like in Java, right? We specify the epic at the beginning and on the top of the source file. Sorry, and it's not necessary to match the directory, right? In Java, we need that. We need to match the directory with the package. In Kotlin, it doesn't matter. We can place the file in an arbitrary place in the file system and just writing the package. It's enough. How to import package? Well, it's the same as in Java. For example, some import Java at util star, right? So let's start with functions. Basically, to write a function, we need the fun keyword at the beginning. And then the name, right, of the function. Then the in parentheses, the parameter types and the name, of course. And then at the end, the return type. Basically, it's something like that. So we have the fun keyword right here, the name of the function, the parameters that will return here, sorry, and the return type of the function. Then, of course, like in Java, we have the body of the function. What else? So, did you notice something weird? And I mean, comparing to Java in this piece of code. Basically, we don't have the semicolon after the line after the return, and that's something that I mean you have in Kotlin, right? You can avoid or omit the semicolons after every line everywhere. I mean you don't have to. If we come back to the import, for example, if you can see there is no semicolon there, and we can write like that. So let's continue. Semicolons can be omitted, right? Let's see other example here. For example, the function main, pick up function main. So we will receive on the right. We can declare, for example, the function main at the top level of the file. We don't need any class to wrap it or anything. We got just it's a first citizen type, right? The function. What else? We don't need to. Sorry, the right are just classes. I mean, it's not a primitive type or anything, just a class, like every collection. We can print print line instead of system out print line. And why is that? Because we have wrappers in Kotlin around the standard Java library functions. And finally, there is no return type. In Kotlin, by default, we are returning always in every function the type unit. I don't know. Sorry. So we are returning always the type unit, and this corresponds to the void in Java. But okay, it's not the same, right? Unit only represents unit, and it's like that. And by default, we are returning. It doesn't do anything. Then the expression body, for example, you can remove the curly braces and the return statement. For example, writing something like this. Here we're returning the sum of these two right integers. And if we have something like this, we can avoid or omit writing the curly braces. Then you can declare default parameters. What is a default parameter is a parameter that by default, if you don't indicate anything, it will contain a value. For example, in this case, I have this function f that will receive a name and then greet, that is type boolean, and by default will be true. I mean, if I call something like, if I call something like f of Gonzalo, for example, my name, by default will include the true in the greet, right? In the greet variable. We'll talk more about it later, don't worry. Then we have the val and var. Basically, we have two different types of two different ways of defining a variable in Kotlin. We can use val, that it's used for defining final values, immutables, right? Values that after they cannot change value. And then we have var for mutable types. You should consider always as a default use val. Why? Basically because it's easier for example, if you have I don't know, multi-threading code, or we will talk again later about that better. Here, for example, we have an example, the value a, right? Val a, it's equal 1. And if I'm trying to reassign some value to a, it will complain, right? The compiler, it will return some compiler error. But in other case, if I have a var c, I can reassign. Doesn't matter. I mean, it's like a normal value in Java. Then the type can be inferior. This is what I was saying before, that I don't need to indicate what kind of type, what type is. I mean, it's statically typed, but the compiler can like know what kind of type if I assigned a value. For example, in this case, I have val b, right, equals 2. I mean, the compiler can know that is an int, right? Yeah, it doesn't need anything else. And in the case that you are using floating point constant, automatically or by default will have a double type for that variable. In case that you want a float or something else, you can indicate with, for example, after the number an f, or a long after the number an l. So it will appear as a long or a float, depending on the case. Then we have a way of easier string formatting. It's called string template. So basically, in a string, you can refer to a local variable in string literals. How? Only putting the dollar symbol, and it's equivalent to string concatenations. To do the core more compact and efficient, of course. And here we have an example. For example, if I have var a equals 1, I can define, for example, a strip variable, right? And sorry, and I can say here that is $a, and it will concatenate the 1 here. We'll put the 1 here. We can also, for example, here in the we have the main function, right? And here I'm concatenating. If I put the curly braces, I can access to some variable member. In this case, it's an array, and I access to the first member of that array. This is putting the curly braces, as you see here. Also, you can nest double quotes inside double quotes. We'll see an example. As long as they are, of course, within the expression. What the expression I mean inside the curly braces. For example, here I'm printing something, and I'm using here the, if you see, this someone has also double quotes, but it's inside the expression, so I can do that. Then one really nice feature of Kotlin is the null safety, and I don't know if you know, but the null pointer exception is called the $1 billion mistake, and it's because of Tony Hoare that in a conference in 2009, he said something like that he regrets to invent this null reference, right? And that it caused a lot of pain and maybe some loss of more than $1 billion because of it, right? During the 40 years that the null reference was there. So basically, that's why it's called $1 billion mistake. And of course, for us, we know that it's one of the most common pitfalls for Java developers. And how it's called, of course, accessing a member of a null reference. So yes, of course, null pointer exception will finish null pointer exception. So Kotlin, basically the Kotlin's type system, is aimed to try to eliminate these null pointer exceptions from our code. How to cause a null pointer exception in Kotlin? There are, of course, there are even ways of doing this, but they are really weird, right? For example, explicit call to throw a null pointer exception, something like throw null pointer exception. That, of course, will cause a null pointer exception. Usage of this operator, double. I forgot the name, but using that operator, we also will cause a null pointer exception. That operator, later we will talk more about it. But it's like, okay, give me whatever is here without caring of anything. External call, of course, for example, if we are using a library in Java library and something returns a null pointer exception, we cannot avoid it because it's not written in Kotlin. And if there are some data inconsistencies during the initialization of variables. So there are two kinds of references in Kotlin. One is the reference that can hold null values, like the normal reference, normal reference in Java, right? And the ones that cannot hold null values. For example, here we have both of them. The first one that is written as normal reference in Java, and that cannot hold null values. And then this, if you see this string with the question mark, this one can hold a null reference. So these two types of variable we have in Kotlin. For example, if I try to assign a null to A, right, to the variable A, it will complain, the compiler, and say, okay, you cannot do that because it's this reference cannot hold a null value. In the other case, if I assign a null to B, of course, you can do that. No problem. What about A? So A will never cause a new pointer exception because cannot call a new reference, right? In the other side, B could, sorry. So let's talk more about nullable check. Basically, in Kotlin, the system will tell you if you want to explicitly call a null reference or not. For example, if we call something like this, remember that B was a nullable reference. It will be a compile error. We cannot do that. Explicit call that we cannot do it. So B should be checked before accessing to its members. How? For example, with an if, right? So for example, if we check before that B is not null, we can access it without any problem. Here, if you check, I don't need to cast it or do something special, right, for accessing. Just after checking, we can access it because the compiler knows that B is not null. Also, there is an easier way, of course, of doing this. We don't have to write if everywhere, if null everywhere. How? With the safe call. So basically, it's an operator, the safe call. It's called safe operator, and you can access to this reference, null reference, safely. For example, here L, right? We have the value L, and we assign B question mark dot length. What will happen here? Well, if the type, if we can access to B, and B is not a null reference, we'll just put the value of the length. And in other case, it will just put a null on L, so it will never access to the null reference. Okay. One thing that L will be the type int question mark because can be null, right? I mean, we can assign something null there. It will never throw new pointer exception because if it's null, it will not access to the member. And like I said, it will assign if there is if B is null and the type of expression is int question mark, right? And of the type of L in this case. So also, if we don't want to assign or to declare a int question mark type, we can use the lbis operator, sorry, with a safe op. So for example, if in this case, L will be, if it's not null, B is not null, the length of B, but if it's null, it will assign -1, right? In this case, it will not be L. It will not be int question mark. It will be an int without the possibility of holding a null value, right? Also, the safe call can be used in chains. I mean, I can use it after every reference, for example, here, and it will access to the final value if all of them are not null, right? Then we have this operator, and use it, on your risk, because you can have this operator will say, okay, give me whatever it is here. I don't care if it's null, it's not null. So use it at your risk. I don't recommend to use it. I mean, maybe sometimes you need it for interoperability matters, right? But normally in Kotlin code, you will not need it. Of course, it will return a null value. And if you are assigning, for example, to a variable that cannot hold null reference, will cause this null point. Like I said, we might throw a new exceptions. For example, here, right? We are trying to access to a member of a null reference. Then we have the safe cast. We saw something of this in the previous slices. I don't know if you noticed, but basically it's used to, for example, in the to avoid these class cast exceptions. And this operator will try to cast to a class, and if not, we'll assign a null to that reference. For example, we have an animal, right? And we try to cast that to dog. If A it's a dog, I mean it can be cast, we'll assign A, and if not, we'll assign a null. Of course, we need to do it a variable that can hold a null reference. Then we have the primary constructors. Why I put only primary constructors? Because actually in Kotlin we can write code using only primary constructors. This is thanks to the default arguments and named arguments. How it is? Let's talk about a little bit about primary constructors. But basically, you can define a class primary constructor, of course. Yes, there in the header of the class. Here, this class defines one constructor here with the constructor keyword, and we'll receive a first name that is a string. The keyword constructor can be omitted, so we can write something like this: class person, first name, and that's it. We are defining one class with one constructor. So this primary constructor is used for specify constructor parameters, of course, like we've seen with this first name here, and then for define properties that are initialized by those parameters, right? What about initialization code? For example, if we want to initialize something, we see that we don't have any block there, right? We have only after the name of the class, the constructor. Well, we can do this using the init keyword. We will write a block with in the init keyword, and this init, this block of code, will execute when we call the primary constructor. For example, here, right? We have the class customer that has the field name, and we have init that will call this code after the creation of one object of this class. Also, you can, as I told you before, you can declare default values and for constructors also. Why you can do this, and that's why I said that you can only, with one constructor, with one primary constructor, you can have multiples. I mean, you can only use one. Why? Because this avoids the needness of defining multiple constructors. For example, here, I have a class user with a nickname and a default value for the is subscribed, right? And so I can create an object user1 with only the name, and is subscribed will take the true value because it's default here. But also I can I can pass some value there, and value 2 will include the name and also value for is subscribed. So, and I can do this with the amount of parameters that I want. So you can make the constructor not accessible from outside. Of course, you can do it. For example, using the private keyword, right? And in this case, the constructor will not be accessible. Let's talk about secondary constructors, because sometimes we need. They are, like I said before, they are not normal in Kotlin. If you're using only Kotlin code, you're not going to use them at all. In Android, you will need them, of course, and they are useful, for example, for external frameworks. Here I have an example. In the case of a view, it's called my button, and I need to define the two constructors, right? Because it's Java code. So I will define the two constructors using the constructor keyword and the parameters that I want to pass. And I will use like a normal parameter. So I can use also secondary constructors. If I don't know if you notice in this code, for inherit some class, I use the colon, right, symbol. And this is define the inheritance. We'll talk also about this. Then I have the properties of a class, right? So basically in Java, the data is stored in field. Of course, we all know it. Usually we use private fields to encapsulate the code. And then for accessing to them, we provide some accessory methods like getters and setters, right? So in Java, the field plus the accessory methods are called properties. In Kotlin, you declare the properties the same way you declare the variables in Java. I mean, for example, here we have this class person, and while declaring this in the constructor, the name and the is married value, I'm declaring also all the accessories method. I don't need to to write a getter and setter to write a property. Here I'm writing everything. Then the compiler will compile and create all these methods by itself. Here, for example, I have a val and a var, right? So, for example, in val, Kotlin will create only, or the compiler actually, will create only the getter because it cannot change. And in case of var, it will create not only the getter, but also the setter of the method. So, like I said, Kotlin will automatically create getter and setter. By default, implementation of accessory is trivial. I mean, it's just set and get, but you can define this if you want also. A field to store, so I will create a field to store, a variable, and a getter and setter. Like I said, the implementation can be modified. And then we have data classes that is basically to avoid what I was talking at the beginning, to avoid all the boilerplate code. For example, the string, the hash code, another that we will learn about it right now. So basically, the data classes auto-generate implementation of all the universal methods. So it's not used for every class, of course, because or we don't need this for every class, or we don't want to do it. But it's all used for that class that you want only for holding data. Can be, for example, the models. So how is it like this? Basically, you have to only add the data modifier before the class. In this case, you can see it here. So you define data class and the name of the class, and then you define in a primary constructor all the properties, right, that the class has. All the standard methods are overridden, right? Which ones, for example, equals. What it will do, this equal in Kotlin, it will take into account the properties declaring the primary constructor. That's why it's important to use them. And we'll check the values of these properties and defining the primary constructors, and we'll check between them, right? For example, if you have two strings in one class and one int, we'll compare the int, the string between them, right? And the int between the two different classes, the object, sorry. Then also the hash code. Also, like equals, we take into account only the properties declaring the primary constructor, and it will return a value depending on the hash code of that ones of those properties. Then you have toString. For example, again, we'll take into account that property declared in the primary constructor. And like I said, the properties that are not declared is important will not take part of this free method. So Kotlin, when I write this, let's come back here, it will create by itself all that method with these two properties. Always the recommendation is to use only real values for all the classes. Of course, not always is possible, right? But that's my recommendation. And why? Because basically you can avoid inconsistencies, for example, with the hash code in case of hash map method. If you change some value, it will not be consistent. And immutable objects, of course, are easier to reason about. For example, in a multi-thread encoding. And because of that, I mean, because the default is to create read-only objects, Kotlin will generate also the copy method, and basically we copy the instance of an object to another object. If there is an implementation of one of these code or final super class, it will not generate the method, right? Then we have all for your classes. I will be talking about hierarchies, delegation, and the object keyword. But first, let's focus in interfaces in Kotlin. They are really similar to Java 8 interfaces. What does it mean? That they can contain declaration of abstract methods and implementation also as well. And what is the difference between interfaces and abstract classes is that they cannot store states like the abstract, right? For declaring the interfaces, we use the interface keyword, right? And for example, in this example, I created an interface with one method, click. If you notice, we use the colon to replace extends and implements. I mean, you can extend a class or implements using the same symbol, the colon. And like in Java, right, the class can implement a lot of interfaces, whatever number you want, but not classes, only one class because it's Java still, right? Then if a method is overridden, you have to specify that it's override. You have to use the override keyword before the method. For example, if I want to implement the clickable interface in my class button, I have to write the override before the function that I want to override. Always, it's mandatory. Let's continue. So what happens, for example, if two different interfaces have the same method implementation? For example, I have a clickable and a focusable interfaces, and both of them implement one method, show off. So what I should do here? So I'm forced to provide my own implementation in the class that implements both interfaces. And of course, like in Java, to invoke the inherits implementations, we use super, the keyword super. And we can put the base type in angle brackets. How is it? We'll see an example. For example, here I have my class button that implements both clickable and focusable. And like I said, I had to provide an implementation of show off because I'm getting from both interfaces, and I put in these angle brackets the which one I want to call, right? Which show off I want to call. In this case, from clickable, and in this case, for focusable. So basically, with this, will print both, like I'm clickable and I'm focusable. Let's talk about these modifiers, open, final, and abstract. Basically, in Kotlin, all the classes are final by default. I mean, I cannot inherit from them by default. Why is this? Okay, it's to protect against fragile base class problem. What is it basically? If, for example, I'm using some library and from that library I'm inherit some class, right? And in some update, someone changed that class, and then in my code I will have problems, right? So it's to protect against that problem. Of course, if you want to allow the creation, you can do it and use the open keyword before the class keyword. For example, here, if you can see, I write open class, then the name of the class. And here I'm defining a class that can be inherited. Also, for all the methods that I want to also allow to the class that inherits this class, I have to write the open keyword. So here animate will be can be overridden. This click can be overridden because it's already override, but this one disable cannot be because it's not open. So it can be only it's final, let's say. Then in case of abstract classes, they are always open because it doesn't have sense to not have an abstract class that is not open. So there is no need of writing the open modifier because they're abstract, right? And it's the same as in Java. Here I have an abstract class. Like I said, I don't have to write open, just abstract. But in case of functions, if it's abstract functions, again, I don't have to write open. But if it's not, if there is some implementation like this, animate twice, this I cannot override, right? But here, stop animating, yes. So let's talk about visibility a little bit. So by default, the visibility of everything is public in Kotlin. There is no, in Kotlin, of course, there is no package private modifier. You know that is the default in Java. And I have this, it's kind of similar modifier, but it's called internal. But the thing that changed is that it's visible only inside a module. So basically, what is a module? Module is a set of Kotlin files that are compiled all together. Why is this? Basically, to protect the visibility of the classes. Because, for example, in Java, if I, from an external class, if I define that is in that package, I have access to all the properties inside the package. For example, I have an total external class, and I define that is in some package of some library. So all these package private like properties will be accessible by this class that I'm defining. So and then I have also private, and this method on our properties will be only visible inside the file that I'm defining, because in Kotlin you don't necessarily have to write one class in one file. You can write several classes in the same file. So you can have several classes, not nested, nothing, and they could access to all the private properties in there. And then in case of protect modifier, it's even easier than in Java because they will be visible only inside the same class or subclasses. So there is no same package or anything, just inside the same class or the subclasses. For example, classes inside other classes, are nested by default. What it means that I don't have to write the. So first, nested class don't have access to outer class, of course. I don't have to write static if for a nested class. I mean, by default, it's like that. But anyway, I can like if I want to access the outer class, I can write the inner keyword, and that class will not be nested, right? Let's talk about inheritance a little bit. All the types in Kotlin are, I mean, the superclass of all of them is any. And to declare an explicit supertype, I use the colon, like I already explained. For example, if I have, of course, I need open, right? Like I was saying. And here I have the columns for a class that inherits from base. What else we can see here? That I have to implement the primary constructor for the base type. So here I'm initializing the constructor, the primary constructor, passing the variable p, right? The methods overrides are explicit that I already explained. I mean, I have to write the override keyword before all the methods that are overwriting. And to call a superclass implementation, I use super, like in Java, right? Delegation. Delegation is really simple in Kotlin. You will see because it's included a first class support for delegation. For example, okay, and use the by keyword. Let's see an example of delegation in without first class support and with first class support. For example, without a delegation as a feature, I will write something like this, right? I have a class delegation collection and like extend collection, and we'll like delegate everything to this field, like to this array list. We'll see that the size is delegated to the list, the is empty, the contains. So I have to write everything if I want to delegate in case of Java, for example. But in Kotlin, I can use the keyword by, and automatically will delegate all the methods from this for my class, right, to the array list I have here. So we only have to write the keyword by to what I want to delegate. And to the end of this chapter, we will talk about object, the object keyword that basically defines a class and create an instance of that class at the same time. And we can use this for what? For example, create singletons. That is called object declaration. To contain factory methods and other methods, of course, maybe related to this class, but that doesn't require any instance. For example, static method. And this is called companion object. And also for Java's anonymous inner classes, that is called object expression. We'll see better this, of course. For example, I have here object declarations that is can be used for singletons, for example. So I write the object keyword and then the name of the class and all the functions. And this can be used as a singleton. It's that simple. So later, if I want to refer to some method of this object, I write the name, right, and then the method, and it's already done. Of course, because it's a object and a class, it can have super types. So I can, for example, say here, it can inherit something after then, right, without any problem. In case of companion objects, it's an object declaration inside a class. I mean, I have the class and I have an instance of an object inside this class. It's marked with the companion keyword. We'll see an example. For example, here I have a class base, and then I define a companion object here, as you can see, and that will create a new object, another object inside of this class, an implementation of an object, right? And for what is used, of course, it's used for replacement of static members in Java, because I don't have static members in Kotlin. So also they are like before, like I said before, they are real objects and they can implement interfaces. There's no problem for that. For example, here I have an example of I have an interface factory, right? And it has a method create, and I create a companion object of that implements factory, and I can define how this create method will act, right? Then I have the object expression that is used, for example, for creating an object in the anonymous class. One example, for example, here, this is really normal example in Java. I have a button that it's define a listener, right? And simply by using the object keyword, I can define this object will implement this interface, and I can define what it will do with the onClick method. That's simple. So I don't need to create a new object, an anonymous object like in Java. Just using the object keyword, it will create the instance of the object. Right now, let's talk about if, when, and the loop expressions, right? Let's start with if. And in Kotlin, if it's an expression. What does it mean? That it can return values. And because of that, because it can return values, there is no ternary operation because operator because it doesn't have sense. It's the same. So for example, if we have a variable max a, I can with if assign like normally like I would do in Java, but also here this will return a or b, right? So that's why it's an expression. You can return a or b and assign to max. If branches can be blocks, and the last expression of the block will be returned. I don't have to write the return because, like I said, it's an expression. For example, if I have this max again, and I'm writing if a is bigger than b, this will first print this and then return the value. I don't need to write anything. The same for b. We'll print first this and then return the value. Right now we are going to talk about when, and basically it replaces the switch operator in Java. Also can be used as an expression or a statement, a normal statement like in Java again. The else branch, it's like the else branch is the default in Java, the default in switch, right? And it will be called if none of the others are certified. One thing, I don't need to write the break all the time. So also you can combine different conditions with a comma. For example, this when x is if it's 0 or 1 we'll execute this, and if not, we'll just print by the otherwise. So you don't need to write any break or anything else. Also, you can use arbitrary expressions. You don't need to use any value, right? For example, here, if it's the same as parse int of s, we'll print this, and in other case, we'll just print the else, the one that is contained in else statement. Then we have ranges. We can define, for example, we can use one with the ranges. For example, here, when x is contained in this range, it's between 1 and 10, we'll do this. And here is check if that is not here, not in, I mean, not there, we'll do other things. And so if no argument is supplied to this one, it can be used to as if else if chain, and then it's easier to see. For example, here I have one, I don't supply anything, right? Variable, I'm just using the lambda expression. And if x is odd, I will print this. If x is, else if x is even, we'll print this, and else something else, I will print this, right? So it can be easily replaced and the if expression for this one. One thing that what really nice thing that you can pass any object to one. For example, here we are passing a set. So if the set match with red and yellow, we will return orange. If the set match with yellow and blue, I mean, doesn't require only integers or strings or whatever. You can pass every object, and we'll compare it, right? For. So let's talk about for that is a little bit different than in Java. And basically iterates over everything, anything that provides an iterator. Basically, yes, it's a replacement of the for each. So for example, if it's a replacement of the for each, how I iterate over and write using the index, can do it here, for example, using the indices method in the right. So this will iterate over the indices. And how to iterate over other values, right? Because in the for, I can iterate several values. So we will use ranges, basically. How? Of course, range is an interval between two numbers. We have two types of intervals. The closed one, this includes 100. It goes from 1 to 100 and includes it. And then I have the open, that is with the keyword until between the two values. So this will go, it's like written from 0 to 100 minus 1, right? Because it will not include this 100. And how use it? Here I have an example. So I say for e in 1 to 100, this is with the closed interval, right? And here I have with the open interval from 0 until 10. So it will 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And for example, what do you think this will do? So let's check it. A variable contains between 100 down to, so we'll go from 100 to 1 in step of 2. So only the even numbers. Right now, let's talk about while. And it's pretty simple. Why? Because it's the same as in Java. Exactly the same. So I have while condition something and do condition while. And they are the same as in Java. So I think it doesn't require any extra explanation. Let's talk about right now smart compile and compiler in Kotlin and type inference, smart cast in this case, and type inference. But first, let's check is and not is operators. Is checks if some class, some object, conforms a given type, right? So, for example, if something is of class this or type this, not is it doesn't, of course, it's the negation of that. And for example, it can be used like this: if object is string, something. If object not is string, something else. Check here that I'm not casting, right? This is the smart cast, and we will talk better later. Here right now. So let's do a really easy example of, to explain it. I think this way is easier to explain it. I have a function that evaluates a simple arithmetic expression, right? Something like 1 + 1 + 4. It will evaluate that expression. And just for simplification of the example, it will contain just one operation, plus, and sum. So it will be stored in a tree-like structure. So each node will be a sum or a number. The num is always leaf node, of course, and the sum has always two children to sum up. I will use the X interface for both of them. So both of them will implement. I have here how we define everything in Kotlin. I don't need anything else. This is all what I need, of course, and I need the eval method. So what if I want to implement this expression? It's a sum of number 1 and number 2, and then number 4. It will be something like this, right? So for evaluate the result, if it's a num, of course I will return just the number. If it's a sum, I will evaluate the left and the right null, right? Return the sum of them. So let's try the function. I have this eval function that will receive an expression. And if E is number, what it will be? Of course, in this case, I'm doing an explicit cast, but I will see that it's not necessary. So I will cast it to a num and then return the value, like I said. And if a sum, I will just evaluate the left and the right. Check here that I'm using SmartCast, right? I'm not casting anything. Why? Because the compiler knows that it's a sum. I mean, I already check here. It's going to enter here only if it's a sum. So there is no needness of casting again. So we can rewrite the sample like this. Here we don't need to cast anything. Just return the value. So right now we will talk about a lot of features related with functions. One thing that I really like, it's the extension function. When I seen it for the first time, I was really surprised of this. Basically, what is it? It's a function that can be called as a member of a class, even if I didn't write the class. For example, in case of string, right? That is in Java already. I can define another method of string called lastChar, and I will return just the last char of the string. How is this done? First, I need the name of the class of interface that I'm extending. In this case, was string, right? Here, the string. Then I need the name of the function. lastChar in this case was right after the dot. And finally, the implementation of the function. Here I have better. So I'm extending and adding to string another method, lastChar, that will return a char, and basically we'll get the last char of the string. And it can be used in any class that I want, any part of my code. With only importing this function, it will I can be able to use it. So you don't need the source code of the class at all. Also use this as you will use any other method string. I mean, you just have to write. For example, if I have a string dot lastChar, and I will have the lastChar, like normal method of a string. Of course, doesn't allow to break the encapsulation. I only can access to the private. I cannot actually access to the private or public members, of course, because I don't have access to the source code. And of course, you cannot override extension functions because they are not members of the class. It's something that you're adding. Let's talk about right now about high order functions. So basically, what is it? It's a function that takes other function as an argument and returns another function. That's its high order function. It can the function in Kotlin can be represented in two different ways, using lambda expressions, or of course a function that is not declared, or using an expression. Sorry, for example, this here. This is a lambda expression. This is a function that I'm passing without specifying this that is a function. Or using function reference, I mean, in a variable, define a function normally. An example, for example, I have this filter function. This is an example of higher order function. So I have a function that receives another function. This is a function that takes a prediction, right? A parameter. And for that, I need a function type for define higher order functions. So how to declare these function types? Basically, I need to write the parameters in parentheses, like a normal function, right? And then followed by an arrow, I write the return type. For example, here, this is a function type. I say that this function will receive an int and a string and will return a unit. If returns a unit, remember that it's the default type, but if it's a function type, I must specify that it return a unit. Of course, for example, here I can define some name for these two variables, right? For what it's going to take. But if I don't want that, it's not necessary. So how we implement higher order functions? So it's the same syntax as a regular function, but we define, right, what kind of function we will receive. For example, here I have this function 2 and 3 that takes a function only that will receive an int, 2 ints actually, and will return an int. So this is a function that receives another function, and we use it like this, right? So if we want the result somewhere, we just run the operation function with two numbers, and there we have the higher order function. Then this Kotlin extra. So there are extras that I couldn't like put all together in some module. So I'm at the end I decide to write about it, to tell you about it. We have operation overload. This is really cool, actually. Basically, Kotlin allow us to provide implementation for predefined sets of operators on our own types, right? So, for example, operators with fixed symbolic representation and fixed precedence, of course, will be. And there are conventions for regulate this operator overloading. For example, it's easier to talk with examples. We have the Unary Operators. For example, this plus a, right? If I write to my class or whatever type a dot Unary plus, I can override this. And for using this, I just have to write this operator. We'll see some example. First, let's talk about all the possibilities here. I can use also the Unary minus or the not, right? And here's this example. For example, if I have the data class point that receives has two integers, right? We'll receive in the constructor. And I can override the operator, writing the keyword operator. And like I said, will be point dot Unary plus. and define how it will how is the behavior with this function. And for using it, I only have to put, for example, minus point, and this will return this exactly, right? A point -1, -2. Is the same for all the other operators. For example, if I want to rewrite the unary plus, I have to, instead of unary minus, define the function unary plus and use it the same with the plus before the object. We'll do that. Also, I have increment and decrement. For example, a plus plus, and I have to override this operator, the inc. A minus minus deck. Of course, both of them must return a value because that's why they do, right? They first, for example, depends on the order. So I have to only write once the inc or the deck, and then the compiler, depending on when you're using it, where you put the plus plus or the minus minus, will first store and return, or return and store the value. Then we have the binary operators that is the same. So I have to override this operator, the plus, for using only the symbol plus, minus, times, diff, right, and rem for multiple, range 2 for the range. It will work the same as range with numbers, for example. That's when we write, for example, 1.10. That is the it's override, right? That operator. Others that we can also write, and I will be speaking all day. I will define all of them. So you can define also index sets, involves augmented, equality, inequality, and comparison. So let's talk right now about inline functions. What is it exactly, inline functions? In case of higher order functions, it imposes some runtime penalty. Why? Because each function creates an object, right? So what if the penalty will be memory allocation for that object, virtual calls. So how to solve that? I mean, what if I can avoid the creation of this object? For example, let's explain with an example because it's always easier. I have this, right? So foo, it's on a function received by a high order, right? Log will receive this foo function. And what I don't want to create an object to contain the foo and then execute it. So I want this. I want that in the same code, all will be executed. So I want this foo in the same line of code. To make the compiler do that, I have to write or mark the function as inline. How I do that? Inline foo, fun foo, right? So here I'm saying, okay, I don't want you to create an object to do this. I want you to try to inline this code inside in the code when I call it. What if I don't want, for example, I have an inline function and I want some parameter not inline? I can do this with, again, not inline functions. And it's the same. You can mark the function as not inline. Why I want to do this? Because the inline functions have some restriction. Sorry. For example, they cannot store states, right? So if I want to store state, I need a non-inline function. In this case, I have, again, I define the foo and will receive another function, and I want to mark it as non-inline. And that is like that, not very simple. Let's talk about right now with, apply, let, and run. They are really useful. For example, with basically perform several operations on the same object without repeating the name. How it is, I mean, You will understand better with this piece of code. For example, here I have the function alphabet, and here, if you see, I'm returning with string builder, and I'm passing this object that is the type string builder. So inside this block, inside the with block, I don't need to repeat the string builder name. This will like point to this string builder. And even it's not necessary to write this. For example, here, what you see, the append, that is not writing this. So you can use as you were inside this object. In this case, I'm returning the last of the block. So basically, what is doing? So converts the first element that is receiving, in this case, string builder, into a receiver. So everything I do in the block, it will be done in this receiver. And applies, of course, the lambda pass second in this block of code. Then we have apply that works really similar to with. The only difference is that also returns the object. For example, here I don't have to write return because it will return the object automatically. So I can write this string builder, apply, and work as if I'm like inside the object. So I can append on this string builder and then make it to string, and it will return this object. Can be used instead of the build pattern. For example, here, if I have a text view, and I'm applying a lot of things like inside the object and then returning the object, right? This will return the object. And then I have let. Basically, like you will be inside of the scope of the object you're applying let. For example, in case of using the safe operator, right? Dot question mark. You can run inside the code, block of code, only if that reference is not null. How is this? For example, here, email. So I'm using email, a question mark dot, and using let. So this piece of code will run only if email is null. And I can write several operations inside. I can do whatever I want. And this block of code will run only if email is not null. Then I have the run that is pretty simple to understand. Actually, it's a combination between let and with. And that's the only difference is that it reads better. So if you want to see more about it, you can check it, but it's not complicated. For a last chapter of this presentation will be resources, how you can, how material to learn Kotlin better or check what I check. There's a book named Kotlin in Action. It's written by the author of Kotlin. It's really good, so I recommend you. The cover is like this and has everything you need for understanding Kotlin. Then you have the doc page. This is the link of the page, and also you have a lot of resources. It has also a blog that there are discussions about Kotlin language. And then you have, for example, the Kedit app that is a series of blogs, right? Of a developer that was writing an application in Kotlin. So it's confusing a little bit because everything is like mixed, but it's really useful. And he wrote the application. He pushed it to a repository, so you can check also the code. And during the blogs, he's also putting the links to the commits he did. So it's really nice. And of course, you have a lot of posts in Medium or Underpath, so you can check also that. There's plenty of information over there. So thank you very much for your attention. And if you have any question, you can do it right now. Okay, so I give just conclude this presentation. I hope you enjoy it. And next presentation, probably next digital forum will be 1 month from now. So stay alert, right, for it.